Welcome to PD On Point, your online component to your science curriculum guide. All right, today we're going to take a look at 5.5a, classifying matter based on physical properties. Now, this one has a lot of components, but we're going to take a look at one specificity. We're going to take a look at relative density, or sinking and floating. Now, I know a lot of you just cringed just now when I said sinking and floating, but we have to remember, in 4th grade, this is how they're taught, sinking and floating. But we have to come in with a new vocabulary of density and relative density.
Now we're going to take a look at a few definitions, the first of which is density. Density means the amount of mass that's within an object. We'll also be discussing in our lab relative density, and that's when we compare densities in comparison to water. Now, taking a look at our example here of a beach ball. Beach ball is pretty large, but when we take a closer look, the particles are very much spread out. When we compare that to the density of, let's say, a bowling ball, which is a similar size and shape, we notice that it is much heavier. And if we look closer, we notice that the particles are much more compact. And that means there's more per area.
All right, now it's time to get our hands on science. Let's actually do our lab. We're going to determine whether objects will sink or float. Now remember, we want to include if it's going to be more dense, it's going to sink, or less dense, it's going to float. Let's take a look. First, we're going to try out some wood chips. They're floating on the top. That means they are less dense than the water. What about items that are similar? I have a plastic spoon and a metal spoon. The metal spoon is more dense because it sank to the bottom, while the plastic spoon is less dense and it rises to the top. Let's try the other ones. We have corks.
Both corks float. They have less density than water. The nail and the coin both have more density, which means they sink in comparison to the water. The styrofoam ball also is less dense.
Now I have two objects again that are very, very similar. Again, we have a styrofoam ball and we have a golf ball. Again, we hear that clink at the bottom, which means it sank to the bottom. It is more dense than the water, while the small little ball on the top is less dense and it floats. Remember, we have this tiny little marble here. Okay? And we talked about earlier, we talked about density, being the particles are so compacted together. Well, that's exactly what we have here. A very, very small object, but very dense. Sank all the way to the bottom. And then we have our wonderful friend here, vegetable oil.
Vegetable oil is less dense than water. It rises to the top. In our QCE model, I've included a section here for a graphic organizer. I've included some of the items that we used in our lab, and I'm distinguishing between whether it's more dense or less dense. I can do this just by using check marks. For this QCE model, I've chosen to include both the chart as well as a diagram and labels. I've shown where all of the materials have fallen in consideration to their relative density to the water. In addition to the chart and the diagram, I can always include written observations of the lab. For the claim, I want to address the question at the beginning of the QCE model: which objects have a greater density than the water? I decided to use the lead forward vocabulary in my claim. For my evidence, I want to ensure that I have a vocabulary bank somewhere for the students to use. I could include them in the actual QCE model, on the board, or even on a vocabulary tent. In the evidence, I'll use my observations and express my details to support my claim. I'll also underline any vocabulary words to help justify my information. In this question, they're asking for a method to remove cups, keys, and coins from a swimming pool. When looking at the answer choices, I noticed right away that we're talking about density. We have less dense, same density, less dense, and same density as water. I'm looking at phone cups, keys, and coins specifically. Now, an option I can use is just like from the QCE model, I can draw a picture. In the diagram, I can illustrate the foam cups, keys and coins in relation to their relative density to water. In your lab, you'll have the opportunity to use a foam cup as well as coins. The only one left out will be the keys. Now, with those experiences, students will be able to determine that foam cups are less dense and float, and coins are more dense and sink. Now, when it comes to the keys, students have to use their deductive reasoning. Keys are similar to coins, or perhaps they have their own experiences about dropping keys into water and understand that they sink. Letter A is incorrect because it states that the keys and the coins are less dense. Less dense means they would both be floating. Letter B states that the cup has the same density of water, which means to be floating about in the middle. So letter B cannot be correct because we know that it is less dense and floats on top. Letter C states that the foam cups are less dense and floats on top and can be removed from the surface. So far, that one sounds pretty good. Letter D states that the keys and the coins have the same density as water, but we know from our diagram they both have more density and they sink. If they had the same density of water, they'd be somewhere in the middle.